Hey, so in this video we're going to be talking about the properties of exponents. So let's first revisit for a quick second a power. So let's say that we have a to the n. All of this is what we call a power. And this number right here, this n, that is our index, and this a value is our base. So the base is the number that repeats, and the n is what tells us how many times it does that, basically. So let's talk about these different properties. So as we look, we can see this first property, our bases are the same. And when our bases are the same, then we're able to take those indexes and we get to add them together. So basically, when we have twin bases that are side by side, we get to add their exponents. Now, if we look at our second property, here we see that our bases, they're the same again, but this time they're stacked. And when they're stacked, you subtract. So let's look at the next one. On the next one, we have this negative index, this negative n. And you can't have negative. If you chance to meet a negative, you cannot let it stay. So you must turn it upside down and take that negative away. Which means that if your negative is represented in the top, or a whole number already, it must move to the denominator. And vice versa. If you by chance had something like this, a 1 over a to the negative n, you would actually rewrite that as just a to the n. So let's look at our fourth one. Here we see our base a is being raised to a 0 index. Now anything to the 0 power is a 1. It doesn't matter what it is, as long as a itself is not 0. So you could have the number 3,275,000, and if you raise that to the 0 power, the answer is just going to be 1. In fact, if you look at the example that they've shown us here, it says x squared plus 1, all raised to the 0 power, and the answer was still 1. Let's take a look at our next one. Here, we see that we have two different bases. We have a base of A, and we have a base of B, but there's only one index. So what happens is that m works just like the distributive property. There's a number outside of the parentheses, and we're going to distribute that in, meaning that the a is going to get to be raised to the m power, and that the b gets to be raised to the m power. Let's take a look at our next example. So here we see our base of a, but this time it's being raised not just to the m power, but it's also being raised to the n power. So it's kind of like that m and n are one's on the tip and one's on the tippity top. So I call that tip top times. So we're going to take that m and the n, and they actually end up getting multiplied together. Okay, multiplied together. So m and n get multiplied. Now, our next property, we see that we're starting with our two different bases. We have a base of A, and we have our base of B, and they're both being raised to the m index, or to the m power. And so it's the same thing. It's on the outside, so we're going to distribute it in. It gets distributed to the top of our fraction and to the bottom of our fraction, leaving us with A, oops, wow, I wasn't expecting that, A raised to the m power, as well as our B raised to that m power. Now our last property is kind of special because you'll notice that we have absolute value symbols in there. So here we have our base of A. It's being raised, in this case, to the second power. So you'll notice that what happened is that our base of A stayed inside of those absolute value symbols, but that the 2 came out. So the absolute value of a is in fact a, and our 2 just came out, so we have a squared. So those are the different properties that we would use for exponents.